Hello everyone, welcome to Stats with Supreetha. In our previous episodes, we learned about variance and standard deviation for individual observation. But in real life, data is often organized into a frequency distribution table instead of listing every value separately. So the big question is, how do we calculate standard deviation when our data is grouped into a frequency table? So let us begin. Let us imagine two classes. In both classes, the average marks are 70. Sounds like both classes performed the same, right? Not exactly. In the first classroom, almost every student scored between 68 and 72. Everyone performed almost equally. But in the second classroom, some students scored 30 while others scored 100. Even though the average is still 70, the scores are spread out much more. This tells us something very important. The mean only tells us the center. It does not tell us how spread out the data is. This spread is called dispersion. Dispersion simply means how far the values are from the average. One of the best measure of dispersion is standard deviation. Standard deviation gives us one, one number that tells us how much the observation usually differ from the mean. If the standard deviation is small, the data is closely packed. If the standard deviation is large, the data is more spread out. Uh, Let us solve a example. Here we have 25 students and the number of credit hours each student takes in a week. Instead of writing every student's data separately, the information is organized into a frequency table. Let us understand each column. Okay, first column is X. This represents the actual value. For example, 12 credit hours, 13 credit hours, 14 credit hours, and so on. The second column is F. This is frequency. Frequency means how many students have that particular value. For example, if X equals 14 and frequency equals 8, that means 8 students are taking 14 credit hours. The total number of observation is represented by N, which is equal to sum of F, the sum of all frequency. Here the total number of student is 25. Before solving, let us understand the steps. Many students feel standard deviation is difficult, but actually it is just a sequence of simple calculation. We will follow these steps. First, calculate sum of xf. Next, find the total frequency, which is sum of f. Using these, calculate the mean. After that, calculate the variance. Finally, take the square root of variance. That gives us standard deviation. If your table is organized properly, everything becomes easy. Okay. Before calculating anything, we will prepare four important columns. First column is x, which contains the value. One more important thing, if in the place of x, if we have a class interval like 10 to 20, 20 to 30, 30 to 40, in that case you should take midpoint as the value of x. Okay. Now the second column is f, which contains the frequency. The third column is xf. This is simply the value multiplied by frequency. For example, 12 into 2 equal to 24. 13 into 5 equal to 65. 14 into 8 equals 112. Continue for every row. The fourth column is x square f. First square the values, then multiply by frequency. Let's see one example. For x equal to 12, 12 square is 144. Multiply by frequency. 144 into 2. That will give 288. Similarly, 13 square is 169. 169 into 5. That will give 845. Continue for all rows. Finally, add all the values. We get sum of f equal to 25, sum of xf equal to 343, sum of x square f equals to 4747. That's all. That these totals are all we need. Okay. Now let's calculate the mean. The mean equals sum of xf divided by sum of f. Substitute the values. 343 divided by 25 equals to 13.72. This means the average student takes 13.72 credit hours every week. But remember, this is only the center. We still do not know how much the students differ from this average. That's why we calculate variance and standard deviation. Now comes variance. Since this is sample data, we use the sample variance formula. The formula is variance equals to sum of x square f minus sum of xf the whole square divided by n, divided by n minus 1. You might notice n minus 1 instead of n. This is because of Bessel's correction. If you have watched my previous episode, you'll already know why we divide by n minus 1. It removes bias and gives a better estimate of population variance. Now let us substitute the number. Sum of x square f equals 4747 and sum of xf equals 343. N equals 25. First calculate 343 squared. That's 117,649. Now divide this by 25. We get 4705.96. Next, subtract 4747 minus 4705.96 equals to 41 41.04. Now divide this by 24. Remember, 25 minus 1 equals 24. The answer is 1.71. This is the sample variance. Notice something very important. Variance is measured in squared unit. Credit hours squared is credit hours squared is difficult to interpret. So we take one final step, that is standard deviation. Standard deviation is simply the square root of variance. Variance equals to 1.71. Take the square root. The answer is approximately equal to 1.3. This is the standard deviation. Notice something very important. The unit is now back to credit hours. This makes interpretation much easier. A standard deviation of 1.3 credit hours means that most students are roughly 1 to 2 credit hours away from the average credit load. Since the spread is small, students have fairly similar workload. Let us quickly revise everything we learned today. Whenever you have a frequency distribution, let us start by preparing 4 columns: x, f, xf and x square f. Next, find sum of f, sum of xf and sum of x square f. Using these totals to calculate the mean, then calculate the sample variance. Finally, take the square root to obtain the standard deviation. Remember, the standard deviation tells us how spread out the data is. A small standard deviation means all observations are close to mean. A large standard deviation means the observations are widely spread. The more problems you solve, the easier this topic becomes. Okay, so practice more. If you found this video helpful, don't forget to like, share and subscribe to Stats with Supreetha. Thank you so much.